8.3 Hypothesis testing based on single sample, the population variation sigma unknown, or the sample size n less than 30. As we mentioned before in confidence interval estimation, in most real studies the population variance is unknown. Moreover, every so often it is not possible to have a significant number of observations, n greater than 30. In this case, it is more appropriate to use a t-distribution that defines the bell shape for lower degrees of freedom, lower sample sizes. The t-distribution is symmetric and bell-shaped just like a normal distribution. However, it possesses heavier tails, which means more observations on the tails. A t-distribution is shown in Figure 8.3 in the following slide. Figure 8.3 shows the t-distribution with degrees of freedom of 5, 13, and infinity. When is it appropriate to use the z-test, and when is it appropriate to use the t-test? This table summarizes the answer to this question. Use z-test in hypothesis testing only when the population variance is known and you have a large sample size, meaning that n is more than 30. Otherwise, use the t-test. Let's have a look at the cheat sheet to be used for hypothesis testing based on a single sample where the population variance is unknown or the sample size is less than 30. Step 1. Make a statement about the population mean. Step 2. From that statement, make a null and alternative hypotheses. Step 3. Read the problem statement carefully and extract the needed statistics to conduct the hypothesis testing, like the hypothesized population mean, the sample size, the sample standard deviation, and the significance level. Step 4. Calculate the test statistic. Step 5. Find the critical value from the t-table by using the degree of freedom or by using Microsoft's Excel, and find out if the test statistic falls in the rejection region. Finally, Step 6. Make a concluding statement. This slide shows more details about Steps 2, 3, and 5 in the cheat sheet, and how to define the null and alternative hypotheses in the case of a two-tailed, left-tailed, or right-tailed test. Pause the video and have a look at where the rejection region is located in the t-distribution. Let's do an example on hypothesis testing with t-test. A random sample with 27 observations has a mean of 22 and a standard deviation of 4.8 was taken from a large population. Is it possible to conclude at a 99% confidence level that the population mean is significantly below 24? Pause the video and use the cheat sheet provided in the textbook to solve this problem. The following slide shows how easy it is to solve the hypothesis test problem by following the cheat sheet. Carefully read the problem statement and follow the 6 steps. Step 1. The population mean is significantly below 24, so this is a left-tailed test. Step 2. Define the null hypothesis. The population mean is more than or equal to 24, and the alternative hypothesis that states that the population mean is less than 24. Step 3. Get the statistics as shown in the slide. Step 4. Calculate the test statistic by using the formula provided. Step 5. Get the critical value from the t-table by using alpha and the degree of freedom. You may use Microsoft's Excel to find the t-score by executing the commands provided in this slide. The test statistic falls into the non-rejection region. Therefore, we fail to reject HO. Finally, Step 6. Conclude. At alpha equals 0.01, there is enough evidence to conclude that the population mean is less than 24. Please keep in mind the following important remark. If the sample size is large, or n greater than or equal to 30, it is possible to use the z-test instead of the t-test, thanks to the central limit theorem, which states that the sample follows the normal distribution for large N. Section 8.4, Hypothesis Test for a Population Proportion. In this section, we are going to use the sample proportion p hat as an estimate of the population proportion p. By definition, a proportion is a fraction of the population or a fraction of a sample. A proportion is usually represented as a percentage. A hypothesis test of proportion will assess whether or not a sample from a population represents the true proportion of the entire population. This is the cheat sheet to use when conducting a hypothesis testing about population proportion. Notice its similarity with previous cheat sheets, except that we have to check the non-skewness criterion that allows us to use the normal distribution in step 3. Pause the video for a few moments and have a look at it. This slide shows extra details on steps 2, 4, and 5 when having a two-tailed, left-tailed, and right-tailed test. Notice where rejection region and non-rejection region fall in the normal distribution. Let's work an example on hypothesis test for a population proportion. A car manufacturing company believes that the percentage of residents in Boston, Massachusetts who own a car is 70%. A marketing manager believes that this value is not true. He surveyed 200 individuals and found that 130 responded yes to owning a car. At a 95% confidence level, is there enough evidence to reject the null hypothesis? Pause the video and use the cheat sheet provided in the textbook to work this problem. The cheat sheet provided uses simple step-by-step procedure to solve a hypothesis test on a population proportion. Step 1. Carefully read the problem statement and make a claim. In this case, the population proportion is different from 70%, or 0.7. Step 2. Define the null and alternative hypotheses. H0 says that the proportion is equal to 0.7, while HA says that the proportion is different from 0.7. Therefore, this is a two-tailed test. Step 3. Get the data from the problem statement. Don't forget to check the non-skewness as shown. Step 4. Calculate the test statistic. Step 5. Get the critical value from the z-table or from Microsoft Excel. Since the test statistic z is equal to -1.543 is greater than the critical value of -1.96, the test statistic falls in the rejection region. Step 6. Make a concluding statement. At a 95% confidence level, there is not enough evidence to reject the claim that the percentage of residents in Boston, MA that owns a car is 70%. Let's move to section 8.5, Hypothesis Testing for a Population Variance, or Standard Deviation. Many real-world decisions require knowledge about the variability of a parameter, also known as a population variance. Like in the case of confidence interval testing, chi-square distribution is used for hypothesis testing for a population variance. Have a look at the cheat sheet used to easily conduct a hypothesis testing for a population variance. Notice that the chi-square distribution is used in this case. The critical value depends on the significance level alpha and on the degree of freedom, which is the sample size n-1. Pause the video and check the 6 steps to make a correct concluding statement. The following slide shows further details about how to conduct the test when having a two-tailed, left-tailed, or right-tailed test. Pause the video and have a look at the chi-square distributions. Time to work an example on hypothesis testing for a population variance. A sample of 15 observations was collected from a population. The sample variance was found to be S squared equals 0.0025. Is there any evidence to suggest that the population variance is greater than 0.02? Use a confidence level of 95%. Pause the video and try it using the cheat sheet provided in the text. Let's go through the 6 steps to make a concluding statement. Step 1. The claim is that the population variance is greater than 0.02. Step 2. The null hypothesis states that HO is less than or equal to 0.02, and the alternative hypothesis states that HA is greater than 0.02. Therefore, this is a right-tailed test. Step 3. Collect the statistics from the problem statement. Step 4. Calculate the test statistic. Step 5. Find the critical value from the chi-square distribution. You can see that the test statistic of 17.7 does not fall in the rejection region. Finally, Step 6. Make a concluding statement. Something like, there is not enough evidence to suggest that the population variance is greater than 0.02 at a 95% confidence level. Let's do another example of hypothesis testing for a population variance, but this time by using Microsoft's Excel. At a cereal filling plant, quality control engineers do not want the variance of the weights of 750-gram cereal boxes to exceed 100 grams squared. A sample of 7 boxes of this cereal with a nominal weight of 750 grams had the weights as shown in the table. Does this sample provide strong evidence that the true variance of the weights exceeds 100 grams squared? Pause the video and try it. Let's do another example of hypothesis testing for a population variance, but this time by using Microsoft's Excel. At a cereal filling plant, quality control engineers do not want the variance of the weights of 750-gram cereal boxes to exceed 100 grams squared. A sample of 7 boxes of this cereal with a nominal weight of 750 grams had the weights as shown in the table. Does this sample provide strong evidence that the true variance of the weights exceeds 100 grams squared? Pause the video and try it. Step 4. Find the test statistic by using Excel as shown. Enter the sample size, sample variance, and the hypothesized population variance as shown, and compute the test statistic to find 18.93. In Step 5, you may either use the p-value or the critical value. This can easily be done by using Excel as shown in the slide. The p-value found is 0.004274, which gives a strong evidence in favor of the alternative hypothesis. Likewise, a test statistic of 18.93 is much larger than the critical value of 1.63. Finally, Step 6, General Conclusion. There is very strong evidence, p-value equals 0.0043, that the true variance of the weights of cereal in boxes is greater than 100 grams square. Pause the video and have a look at this table that summarizes the 4 types of hypothesis tests that we went through in this chapter. Notice that we need to check for the normality and non-skewness in the data. Additionally, notice when the z, t, and chi-square distributions are used. Keep this cheat sheet handy when solving hypothesis problems. Here again, the same cheat sheet is given in a flowchart format. Pause the video and familiarize yourself with it. For more lessons on descriptive and inferential statistics, check out our textbook, Illustrated Statistics for College Students, available on Amazon. Thanks for watching.